Good morning. This recording is for Pre-Algebra Chapter 7, Lesson 3, two-step equations with fractions and decimals. This is something that you need to absolutely know. If you don't know this, you're going to really struggle in Algebra 1. It's something that comes up a lot. You got to know how to do this, both for clearing fractions and for clearing decimals. Okay? So, one fraction. When the coefficient of a variable, that means the number in front of a variable, is a fraction, we're going to multiply the reciprocal to solve. Basically, you're dividing the fraction on both sides, and when you divide fractions, it's multiplying the reciprocal. So you can kind of skip the whole divide by the fraction and then do the reciprocal if you just multiply by the reciprocal on both sides. And this again goes back to Chapter 6 material. All right, you must have all other numbers moved away from the variable for you can do this, okay? So when you have the two-step equations, you need to make sure that you pay attention to that. All right, so the first problem is -7/10 times k plus 14 equals -21. So I'm going to go ahead and get everything away from k before I worry about taking care of the fraction, because again, low priority stuff first. I need to take care of addition and subtraction before I take care of multiplication and division. So even though I'm multiplying by a fraction, I still need to take care of the addition and subtraction first. So I'm going to subtract 14 on both sides. The positive 14 and the negative 14 annihilate each other. And I'm left with -7/10k equals -35, because -21 plus -14 is -35. Now I'm ready to multiply by the reciprocal. The reciprocal of -7/10 is -10/7. So the negative stays with it even though you're taking the reciprocal. So I'm going to multiply with the reciprocal. And remember that negative could be on the 10, it could be on the 7, it could be in line with the fraction bar, and it still means it's negative and it's still okay. So remember, there's three ways to write a fraction. You could do -7/10, you could do -7/10, or you could do 7/10. All mean the same thing. Okay, moving on. So those are annihilate each other. And what I do on one side, I have to do on the other. So I have to multiply -35 times -7/10. And I'm going to simplify before I multiply. 7 goes into itself once. 7 goes into -35 -5 times. K is by itself because that whole thing got annihilated. And I'm going to end up with -5 times -10, which is positive 50. Yep, or just 50. Or 50/1 means the same thing. Okay? So, test it. Plug the answer into check. So I'm going to plug in 50 where I saw k, and I'm going to go ahead and do the math, and guess what? It's going to work out. Smiley face. All right, so let's go ahead and talk about if I have two or more fractions in an equation. This is what we call clearing fractions, getting rid of them all at once. Basically, you can do this so that you don't have to deal with fractions anymore. And it's a spectacular thing because I know most of you guys hate dealing with fractions. So if you can get rid of them, you don't have to add or subtract them. You can do it so that they become integers, which are whole numbers, either positive or negative, and that's that. And you just take care of it. Okay? So you can multiply both sides of the equal sign, and that means every single item in the equation. You're multiplying the fractions by this number, you're multiplying the variables by this number, you're multiplying whole numbers by this number, or any other integers that you have. Everything gets multiplied by the LCM. That would be the least common, well, it's going to be the least common denominator in this case, but you find it the same way you find the LCM, which is with the upside down cake, which even though it seems a little, like, Miss DH, it's so from like 4 chapters ago, just keep using it. It's okay if it works for you. I'm going to use it. So use that LCM/LCD upside down wedding cake thing to your advantage and use it well. Okay? So, and then just remember, you got to get really good at this, guys. So practice this now. Get really good at it because it's totally going to be useful from like chapter 2 to the end of chapter whatever of Algebra 1. All right? It's very useful, so use it to your advantage. All right, so let's go ahead and figure out what the LCM is, or the LCD of 12 and 6. All right, so then that's, again, because I'm taking the denominators. So that's why I'm trying to find the LCM/LCD of 12 and 6. So 12 and 6, well, that would be 6 times 2 times 1, which is just 12. So guess what? That's what I'm going to multiply every single thing in here by. I'm going to multiply it all by 12. I'm going to multiply the -7/12 by 12. I'm going to multiply the y by 12. I'm going to multiply the 1/6 by 12. Everything gets multiplied by 12. Everything. The only thing that doesn't get multiplied by 12 is addition signs, equal signs, subtraction signs, multiplication signs, and division signs. And even then, the division signs kind of get multiplied because they're usually written as fractions. So everything gets multiplied, guys. Everything in there, all right? Everything. And I'm going to like play it back for you. Everything, all numbers, fractions, variables get multiplied by the LCM, also known as the LCD. Everything, okay? I can't stress that enough. Everything gets multiplied, not just the fractions. The variables get multiplied. If you have any whole numbers in there, any integers, they all get multiplied, okay? So let's go ahead and take a look at what that looks like. So I'm going to have 12 as a fraction, which is 12 over 1, times negative 7/12 plus 12 times y plus 12 as a fraction times 1/6. All right, see? I'm multiplying this 12 times everything in there. Excuse me. All right, so let's go ahead and multiply before I simplify. So there we go. So the 12 over 1 times negative 7 over 12 equals negative 7. It's pretty cool. And then I have 12 times y, which is just 12 times y. And then I have 2. Because 12 times 1 is 12, 1 times 6 is 6, 12 divided by 6 is 2. There we go. All right, and now I'm ready to just solve the two-step equation. All right, so I'm going to add 7 on both sides, which is going to give me 9, and then I'm going to divide by 12 on both sides, which is going to give me 9/12, which does simplify down to 3/4. But when I go in and check it, since my common denominator is 12, I'm actually going to use 9/12 because it's already in my common denominator. We're going to test it up there in the upper right-hand corner if you don't know what I'm talking about. So let's test it. So I am going to plug in 9/12 wherever I see y, because that's what y equals. And I'm going to go ahead and add. So, and again, I'm using the 9/12 because it's common denominator. It allows me to add. If I used 3/4, I'd have to change it to get to 9/12 anyway, so I might as well use the non-simplified version to test, and I'm going to get 2 over 12 equals 1/6, but if you simplify 1 over 12, you get 1/6, which works. Smiley face. All right, next problem. What if I have decimals? Well, guess what? You can clear it very similar to the way that you clear fractions. You can clear decimals by multiplying the entire equation by the smallest decimal place, aka the place value with the most decimal places. Well, this example is not spectacular because A, they don't all have different place values, and B, they're all the same place value, which kind of goes with A. Okay, so let's go ahead and just take the simplified problem. If you need another example that's got some like crazy stuff going on, go ahead and check out the notes for Chapter 7, Lesson 3. There's some crazy ones in there that I work out for you so that you can see why you're multiplying by this stuff. It also gives an example of multiplying a whole number by the decimal. But just remember that when you are multiplying by the decimal, the number of zeros, or excuse me, when you're multiplying by like a 10 or a power of 10, which would be like 10, 100,000, 10,000, 100,000, million, blah, 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 the number of zeros tells you how many times to move the decimal that you're multiplying by that number. Okay, so moving on. So what is the smallest place value for this? Well, it's the tenths. All right, so the smallest place value is the tenths, which is the first decimal place. Remember, if it's the second decimal place, it's going to be the hundredths. If it's the third decimal place, it's the thousandths. So we're going to multiply the entire equation by 10. Tenths, 10, get it? Yeah, tenths, or 10 tenths. So if it was hundredths, we'd multiply by 100. If it was thousandths, we'd multiply by 1,000. Okay, but again, we have to go with the smallest or the most decimal place when you're doing that, because if you have different decimal places, you want them all to be multiplied by the same thing, and if you multiply by a smaller power of 10 than what is needed, you're not going to clear all the decimals. Okay, so everything gets multiplied by 10 in this case. Numbers, decimals, variables, everything. Okay, so let's multiply this whole thing by 10. And again, everything gets multiplied by 10. The 1.5x gets multiplied by 10. The 3.6 gets multiplied by 10. And the 2.4 gets multiplied by 10. So 10 times 1.5, well, really, you're just moving the decimal place over 1. Right? And that's how you get to 15. The same with 3.6. The same with 2.4. So 10 times 3.6, 36, because you're just moving it over one. 10 times 2.4 is 24. Now you have a bunch of lovely, lovely integers. Lovely integers. And now you can solve for x because you know how to solve two-step equations. Right. So let's go ahead and add 36 on both sides because the opposite of minusing 36. We're going to get 15x equals 60, divide by 15, divide by 15, x equals 4. And again, you can plug it back in to check. So test answer by plugging it back in, multiply 1.5 times 4, you're going to get 6 minus 3.6 is going to give you 24. Smiley face. Beautiful. All right, next up, we have for local phone service, the McNeils pay $9.95 plus 35 cents per minute for local calls. So even if they never picked up their phone once, it still costs them $9.95. But the moment they pick up their phone and maybe order a pizza, it's going to cost them 35 cents per minute. So at the end of the month, to maybe order that pizza, it's going to cost them $12.75. Okay, so we need to figure out how many minutes they picked up the phone for this month. So what we're going to do is we're going to solve the two-step equation, and we are going to subtract $9.95. Now, you can go through and clear this fraction. And actually, I should do that, and I'll show it to you in a second. So you don't really have to, because you guys have a calculator for this particular one, and it's dealing with money. I think you can handle it without clearing the fraction, but just know that clearing that fraction with decimals would also work. Okay? So we're going to minus $9.95. And just remember that the $9.95 is the base rate to have the phone service. They're going to pay it no matter what. And then the remaining amount, after I subtracted $9.95 from their phone bill, which is $12.75, when you get the amount they spent only on local service per minute, not including the base rate. Divide by 35 cents, divide by 30 cents. They spent 8 minutes on the phone. Okay? But again, you could have gone through and cleared this fraction. Well, these decimals. They're not fractions, they're decimals. What's the place value? Well, it's the hundredths for all of them. So if I multiplied this thing by 100, we're going to get 995 plus 35m is equal to 1,275, which almost seems like extra work. You guys are familiar with money. You probably would want to use a calculator for this specific problem, but especially if you have a bunch of different decimal places going on, this is where it's going to become very handy that you clear the decimals. So you might not see why it's important now, but trust me, it comes in really important later. Okay, I'm done. Bye, guys.